Aloha and welcome back. Now we're going to be talking about encryption. So encryption, let's go ahead and open up our textbook. So encryption is the process of encoding or scrambling a message. A lot of the stuff here, we're just going through definitions, but we need to have this in order to understand what we're talking about. We're talking about encryption, decryption, and things like that. So we've got a lot of terminology here. You just have to go ahead and learn it. There's a couple things in here that may not be as intuitive, but for the most part, I think that you'll understand what we're talking about here. So starting and going back over again, we've got encryption. That's the process of taking plain text and turning it into ciphertext. It's encoding or scrambling a message. The opposite of that, the opposite or the inverse of that, I should say, is decryption, and that's taking something that's scrambled and unscrambling it. So it's decoding it. You can say it's changing ciphertext into plain text. So the encryption and decryption process that we're talking about here, they follow a specific sequence of instructions, and we call the sequence of instructions an algorithm. You've probably heard of algorithms by now at this point in programming, things like that. But an algorithm is a sequence of instructions that you go through, whether you're encrypting it or decrypting it. And then a cipher is an encryption or decryption algorithm. So that's what we're talking about. The cipher is going to be that algorithm that we go by to encrypt or to decrypt. So an encryption algorithm transforms a plain text into a ciphertext using a key. A key you can think of as a string of bits, a bunch of ones and zeros all together. And then a key space is a set of all possible keys. So you have your one key that fits, but then your key space is the number of all possible keys. So that these are all definitions you need to learn. And a plain text is an unencrypted or unscrambled message. And as I mentioned before, ciphertext is an encrypted or scrambled message. A decryption algorithm transforms a ciphertext into a plain text using a decryption key. And remember what we talked about before with symmetric versus asymmetric. We're talking about, symmetric uses the same key to do encryption and decryption. And then you've got asymmetric, which uses two separate keys there. So that's what we're talking about here when we're talking about these decryption key and encryption keys. So now we're going to talk about the key length. So we have a key length, and that's the size of the encryption key. That's going to be measured in bits. Remember, bits are just a bunch of long sequences of zeros and ones here. So the longer the key is, the more secure it's going to make it by increasing the number of possible combinations that you have. So it's going to, the more you have, the more resilient it's going to be against brute force attacks, which you're just trying it one after the other, and your unauthorized decryption attempts. So to enhance the encryption strength for shorter or simpler keys, so if you have a key that's shorter, there's different things techniques that they use to make them longer artificially. Those are called key stretching. So key stretching is the process of artificially increasing a key's length and complexity. So key stretching makes the keys that are a little bit more resistant to the brute force attacks, even if they're initially weak because they're a short length. So these are the definitions. All the ones here in bold. These are the ones you need to learn. Um, We're going to go down here, lots of work to do in between. So properties of encryption algorithms, we've got two here. They're going to be confusion and diffusion, and they're describing relationships between two different things. So don't get confused about this. Haha, confusion. See? Fun. All right, confusion is a secure encryption algorithm property that ensures that changing a single bit of an encryption key, so the encryption key that does the encrypting from plain text to ciphertext, so just changing one little one little bit in the encryption key is going to impact most of the ciphertext bits. So just making a little change in your key should result in most of the ciphertext bits being shifted or being impacted. So the confusion property we're talking about here, that hides the relationship between your ciphertext and the encryption key. So if you just change a little bit of the encryption key, a lot of the ciphertext changes. So it's hard to see what the relationship is between those two. So that's the property of confusion. The other one we're going to talk about here is diffusion. So diffusion is a secure encryption algorithm property that ensures that changing a single plain text changes about half of the ciphertext. So you've got your plain text over here, you got your ciphertext over here. You're using a key to do the transition there. So what we're talking about is if one little bit over here changes, when you apply that key to it, it should affect at least half of the bits in the ciphertext that comes out. Conversely, or inversely, if you change a bit in the plain text or the plain text, it should affect at least half of the bits in the ciphertext. So going each way, if you change a little bit in given the same key, changing a bit of the plain text should affect at least half of the resulting ciphertext. And again, going back the other way, if you change a bit in the ciphertext, it should change at least half of the bits in the original plaintext. And that property is known as diffusion. And then we have a basic principle here called Kerckhoff's principle. So Kerckhoff's principle states the security of a cryptographic algorithm should depend on the secrecy of the key that we're using, not on the secrecy of the algorithm. The algorithm is known by most out there. All modern systems that are used, for the most part, they're not secret. They're well known. The algorithms are really well known. The secret sauce here is going to be your key. The secrecy of the key is the crux of the whole thing. So Kerckhoff's principle, it states that the security of your algorithm is going to depend on the secrecy of the key. We're not talking about the secrecy of the algorithm. We want everybody to know how to do it. We just don't want them to know the secret key to do it. So the details of the most widely used encryption algorithms, they're all publicly known. And they've been subject to extensive cryptanalysis, so it really comes down to the key itself. And the complexity of that key is the key here. The key, huh? Another dad pun there. So that's it for this section. Again, we're going through basic concepts here. So go ahead and look at all your bolded words here. If we don't have these finished in our study sheet, go ahead and add those to it. But know the definitions up here. Know also Kerckhoff's principle and the two principles of confusion and diffusion. And remember, when you're answering questions on test, a test isn't going to ask you to give the definition of confusion. It's not going to ask you to give the definition of diffusion. What it's going to do is it's going to show you an example and it's going to say, hey, is this confusion or is this diffusion? So think about that in your head. Go to ChatGPT or Genesis or something, or not Genesis, Gemini, and ask it questions like, what's an example? Give me 3 examples of using confusion, or give me 3 examples of using diffusion in cybersecurity or something like that. So, or in encryption algorithms, that's probably the better way to ask it. So go ahead and try that out. And that'll do it for this section. So if you have any questions, as always, feel free to reach out, send me an email. I'll set up a Zoom session if need be. But hope you've enjoyed this. This is our introduction into encryption, and I'll see you in the next video. Aloha.